Hello, students. Welcome back to the next lecture, which is lecture number 7 on the classical electrodynamics. And in the last class, we have actually in the middle of a particular derivation and then we stopped there. So, actually, we are going to continue there. So, you already know the introduction of what we are doing. Essentially, we are solving the Laplace equation in the three dimensional polar coordinate system. So, we are exactly in the middle. We will discuss on the related topic, namely how the 1 divided by r minus r prime, okay, the standard expression for the green function, right, for the potential. You always remember 1 divided by r minus r prime as the green function for the electrostatic potential. So that expression, how it can be rewritten. And then we will see how the solution to the Laplace equation can be rewritten in terms of 1 divided by r minus r prime. So these things you'll be able to understand once we complete the solution to the Laplace equation, and at that time probably I will give the required introduction. So you should also follow in the same order. Like randomly, if you're going to see a particular video lecture, then you may not be able to follow it correctly. So I am uploading the videos in the appropriate order. Okay, that means if this is the seventh lecture, then the sixth lecture happens to be the prerequisite or the continuation. Okay, so you are not supposed to directly see the seventh lecture and then the continuity you may not be having. Okay, if you already studied and just want to learn something, that's fine. But if you want to follow a particular order and then take the one semester course, then I am trying to give it in the appropriate order. So that is what I would like to say. So you also try to maintain that the playlist that I am adding will be in the correct order. Okay, lecture numbers you follow, and then it will be comfortable for you to go back to the previous lecture or move on to the next lecture. So that will be comfortable. Okay, so now I will I'll go to the board, and then let us see what is the continuation. So you now know what is the our plan now, that we are interested in somehow making a connection between, or at least we would like to know what is this quantity r minus r prime in our expression. So to learn what is r minus r prime, because everything we are going to discuss in the spherical polar coordinate system, I have taken a sphere, and then we need an r vector, and then we need an r prime vector. If you have two vectors, then we can discuss. So it would be better to visualize these vectors, how the vectors are there in spherical polar coordinate system, and then we can ask the question how to obtain some kind of relation. So let me first of all explain what is this diagram. This diagram is simply representing two vectors. That's all about it. There is one vector r, okay, which is equivalent to r comma theta comma phi. This particular point, okay, you have a red color point here, right? That point is given by r theta phi, and if you draw a line from the origin to that particular red line, that is called the r prime vector. And similarly, there is another point, okay, somewhere on the space, which means three-dimensional space, another red color point. And if you draw a line from the origin, this white color line, and if you join that, that is called the r prime vector. And the three coordinates of the red color point correspondingly will be r prime, theta prime, and phi prime. So that is clear. Then what is this black color line? This black color line represents the distance between the 2 points. And that distance between the 2 points is the quantity that we are interested in, namely the absolute value of, and that is what is modulus of the r vector minus r prime vector. This is the actual quantity which we are interested in. If you know this, we can always find out the inverse of that. Okay, 1 divided by. So basically, this is the distance between the 2 points uh, in the space. And of course, this doesn't pose any difficulty, because from the coordinate geometry, you always know what is the distance between the 2 points. If you have x1, y1, z1, x2, y2, z2, then what is the distance between the 2 point means you already know, square root of x1 minus x2 whole square, etc. So the problem looks fairly simple. That's all about it. This distance is only that quantity, so it is fairly simple. This is a straight line distance. So that point I would like to emphasize. The distance between the 2 point, any point, it need not be on the surface of the sphere, by the way. The 2 points need not stay on the surface of the sphere. That means r and r prime need not be equal. Is the point is clear? If both the points are on the surface of the sphere, then r and r prime will be equal value. Okay, so one point may be above the sphere and one point may be inside the sphere. Anything is okay. So r, this is r and that is r prime. That is the point. Second point is that the distance between the 2 points, what we are interested to calculate, is the shortest distance through a straight line, and therefore it is a straight line distance. Okay, not the curved one. So there are some lines are showing like this, right? It's a curved one. So we are not going to find the distance along the curvature. That distance is that story is different. That is known as the geodesic distance. Okay, we are not going to talk about the geodesic distance now, but instead we are going to discuss the simple straight line distance. That is, what is the minimum distance between 2 points in the three-dimensional space. Okay, we are bringing the spherical polar coordinate system to bring r theta phi. That's all about it. But other than that, there is nothing to do with the curvature, etc. So here there is no connection with that. So the problem is fairly simple. I would like to draw this particular diagram in order to demonstrate where is theta and where is phi. Okay, otherwise the calculation you would not know what to do. So where is theta and where is phi? Let us see. Once you have r comma theta comma phi, this particular point, and you also have drawn the vector like this, theta has to be measured from the z-axis only. This is how you have to measure. Theta has to be measured from the z-axis only. Therefore, if you draw like this, that much is the theta. And similarly, if you draw a line like this, I have not drawn it, but in case if you are drawing from here, you follow this from the red color z-axis to the white color r prime, this vector. If you draw like that, then that will be the theta prime. I have not shown all the variable because the diagram will look little clumsy, so that's why I did not show. So theta prime will be that. That is okay. Then what about phi? So how to measure phi is that corresponding to the original vector, that this particular vector, you take the projection on the horizontal plane. Horizontal plane means the xy plane. So on the xy plane, you have to find out where is the shadow of this vector. So the shadow of the vector is this dotted line, white color dotted line. Okay, so this long pencil, if you assume that this is the pencil, then this small thing will look like the shadow of the pencil, provided that the light is shined from the above. Vertically down like this, you have to shine the light. Then if you shine the light like that, then this long pencil will look this much a small pencil. That is the shadow. First you have to do that. Once you do this particular shadow is now on the horizontal plane. Can you see the horizontal plane? You connect this, and similarly you draw like this, then that will be the horizontal plane. So this particular small line is now on that particular plane, horizontal plane. Once you make this construction, then you start from the x-axis and then measure what is the angle. That angle is the phi that you are going to keep here. So this is how the r theta phi is going to come for this coordinate system. And similarly, you'll have to repeat the procedure for the second point r prime. So there is a white line here. So you have to draw the corresponding projection on the horizontal plane. Like this you have to do. Then you have to draw a dotted line, and then you have to measure the angle up to that. Then that will be the phi prime. So actually what I am trying to say is that you have the numerical values for r theta phi, you have the numerical values for r prime, theta prime, phi prime. So all these things are available. Now the question is, how are you going to determine the distance between the 2 points? This is the first question. Two questions are there. First question is, how are you going to determine the distance between the 2 points? Second question is that we will come later, but let me tell the question first of all. Second question is, what is the angle between the two vectors? One vector is r, that is one vector is this white color vector. Second vector is another white color vector here. There is an angle here, right? What is that angle? That angle is not written. That angle is not theta. That angle is not phi. It is also not theta prime. It is also not phi prime. You know it, right? Because theta is here, phi is there. I already told you where theta prime will be there, phi prime will be there. So none of them will come that will fit in between these two white color vector. No, white color vector. That means r and r prime. So the question is clear, right? What is the angle between r vector and r prime vector? This is the second question. So these two questions, if you address, okay, that means if you try to find, then we will be having an expression that will give you a clue, okay, how the Legendre polynomial and the e to the power of im5, they are connected to the 1 divided by r minus r prime, or we will say r minus r prime. So you see that the distance between the 2 points in the three-dimensional space is somehow connected to the Legendre polynomial. That is what I am trying to convey this message to you. Okay, that is what all about it. And let us now proceed how to do the calculation. The calculation is of course quite simple. There is no difficulty, but where is the clarity should be there is how you measure the theta phi, how you measure theta prime phi prime, and once you have these four numbers with you, four numbers, theta phi and theta prime 4 prime, four numbers are there with you, how to find the angle between them. Okay, that is the second question. First question is how to find the distance between them. First of all, I want to know the distance between them. So these two calculations are quite simple. Let us see how to do that. So the methodology I already written, quite simple. The r theta phi is in polar coordinate system, right? You simply convert to the Cartesian system. And once you convert to the Cartesian system, you know the formula, square root of x1 minus x2 whole square plus etc. So therefore, the methodology is quite simple here. And therefore, let me write down. Let us now see how to convert it. Isn't it? The conversion is also quite simple. You know how to convert, right? The conversion is simple. How it is simple? Let us see. R theta phi is there. I want to convert to xyz. Is it clear? R theta phi is available with you. I want to know what is xyz. So the transformation equations are the standard equations that you know. Now how to write this equation is, first of all, you start with this r cos theta, then you go in the upward direction. R cos theta, r sin theta. Once you finish the sin theta, then you write down cos phi, sin phi. Okay, so if you go like this, it will be easy to remember. If you know how to remember in other ways, it's okay, fine. Okay, so this is the easy way to remember, because r cos theta, r sin theta is something that you know from school. So that is why I am telling. So you write from the bottom r cos theta, r sin theta. Both of them are same, r sin theta. You finish this, then come here. Again you write down cos phi, sin phi. That means r cos phi, r sin phi. Anyway, r is there here. So always you are going to write down r cos theta, r sin theta. And once again you are going to repeat r cos phi, r sin phi. So cos sin will be repeating. You see this cos sin, once again cos sin. So you have to go up like this and again come down like this. If you write like this, you can simply write down. There is nothing to, there is nothing difficult to remember anything. It's quite simple. If you maybe just once at least, I will show you what I'm trying to say. Of course, I explained this, but what I'm trying to say is that you always start with the last one, r cos theta, then go in the upward direction, then you write down r sin theta. Then once again copy the same thing, because r cos theta, r sin theta is the usual two-dimensional polar coordinate system. But we need one more thing, but there is nothing other than these two. So let us copy the same thing. So r cos theta, r sin theta is over. Now cos sin is there, right? That order we have to maintain. Cos sin is the order. So cos is over, sin is over. Similarly, now I have to write cos and then you have to write down sin. But theta is already over. Therefore, you put a phi. So this direction you have to maintain. So if this is z, then this is y and this is x. So if you write like this, there is nothing to remember. Or if you try to remember, you'll make mistakes very easily, because if you interchange theta and phi, that's all. Everything is wrong. So therefore, you should not make mistakes. Otherwise, the whole calculation will go wrong. This is the easy way to somehow manage and then write down correctly the expressions. That's what I was trying to say here. And this is the first point, r vector. And similarly, for the r prime vector, there is nothing to do. Everywhere you put a prime. So everywhere, the same formula you write down, put a prime here. So I have two sets of points, r theta phi and r prime theta prime phi prime, and which means that I got the values. Values means numerical values I got for the xyz and also for the x prime, y prime, z prime. So once I have Cartesian values, then this particular formula is well known to you, and substitute the numbers, and then I'll be able to get the distance between the 2 points. But that is fine if I convert it into numerical values. Everything looks fine if I convert everything to numerical values. But now I don't want to convert anything to numerical value. I would like to keep it as the variables like sine theta cos phi. In that case, what to do? So in that case, what to do means you directly substitute x here. You have r sine theta cos phi, right? That expression you bring and substitute here. And where is x prime? X prime is there. This is x prime. So take the r prime sine theta cos prime, and that expression you bring it here and substitute here. Similarly, y and y prime substitute, z and z prime you substitute from here, and then you square it and take the square root, and that's all. If you do that, then we will be getting an analytic expression for the distance between the 2 points instead of numerical value. So let us see now how it looks like. Okay, the expressions are fairly simple. There is no difficulty. So therefore, let me move further and then show you how the substitution is going to be there. So you put a square root, or here, yeah, I would like to tell here. So I don't want to put this square root here. To avoid putting the square root, I am squaring here. You see the d square I have written. Therefore, you don't have to worry about the square root. That is the advantage. And let us substitute x is equal to r sine theta cos phi, etc., etc. All these things I am going to substitute. Okay. So you can now, there's nothing to explain now. Let me therefore write down the big expression. You only have to verify whether I am writing correctly or not. So two things are over. Then plus z minus z prime. So r cos theta minus r prime cos theta prime whole square, and that's all. So square root, okay, no need to take square root because left side we have written square. And now you use the simple a plus b whole square formula. Okay, it may be boring, but now there is no other way. We have to expand and see how to simplify. So simply I am using the a plus b whole square, and then let us see whether any simplification is possible or not. After that, what is it? No, there is a minus. Okay, then I will get 2ab cos theta. Sorry, 2ab, no? Then I'll get sine theta prime, cos phi prime. That's all. Then that term is over. Then the second whole square term, let us write down. Minus 2r r prime sine theta prime. Then you have a sine phi prime, and that's all. The last one will be much more easier. R square cos square theta plus r prime square cos square theta prime minus, okay, 2ab term. Okay, it looks a little lengthy, but it is quite simple. Let us try to combine terms. Let me highlight and show. So this white color highlighting, another highlight I will do. So can you take something common and then add? So you can see, r square sine square theta, if you take common, you can simplify. Similarly, there is another set of terms. Let me highlight in another color. So we will combine green color with green color, white color with white color. Okay, we will add. So if you do that, and once again that blue color, I will take another color, maybe blue, and highlight another one. So this particular 2ab term we will combine together, so that some terms are there common, no? So that's why. And the last terms, there is nothing is there, so let us not do anything. So let us now combine how it looks like. R square sine square theta, if you take common, then that becomes 1. Similarly, if you take an r prime square sine square theta prime, then the again that becomes 1. Okay, then you have a minus 2r r prime into sine theta prime. If you take common, the left out expression can be written as cos a minus b formula. Okay, whatever left out can be written as cos of a minus b formula. Over. So that is why we are happy that some kind of simplification is there. And then the last thing, there is nothing to do, so you simply copy that. So here there is no more simplification. So, and after this we can now think whether anything is possible. Now once again you see, Interestingly, once again, some terms can be combined. So I'll put tick here. So one tick here, there also one tick. These two you can combine. I'll put a double tick here and once again double tick here. These two terms you can combine. So if you combine them, I'll be getting r square plus r prime square. Then you get a minus 2r prime open bracket. Then you have a cos theta. Then you have a cos theta prime. Then plus another term is coming. So let me open a bracket. Then it is sin theta prime into the term cos of 5 minus 5 prime. That's all over. Close bracket, close bracket. Hope that this is clear, right? This r square, if I take common, you are getting sin square theta plus cos square theta. So that term is becoming 1. Okay, so r square into 1 was there. That is what I mean to say. Similarly, r prime square into 1, because sin square plus cos square is 1. So similarly here 2rr is common here, like that I have taken, and then if you take this particular term here, I think there is no common term, so I have written here this particular term plus whatever is there here. But only thing is that this bracket I am putting optionally, otherwise you think that these two can be added. Okay, your mind will always work like that, no? These two if you add, no, you can always write down as cos theta minus theta prime, but that is not correct because there is a product here. Okay, so to avoid the possible mistake, I am putting an additional bracket here. Okay, that point you take care. So almost this, that's all. There is nothing we can do after this. This is the expression ultimately we have for the distance between the 2 points in the spherical polar coordinate system. The expression may be looking a little lengthy, but that's okay. This is anyway the distance between the 2 points if you don't want to convert to Cartesian system. Now what is the advantage is that I can directly substitute r prime theta theta prime phi prime numerical value into this formula and then get the distance. Okay, so that is the advantage. That is the reason why we have done this kind of expression. Okay, so this now if I take a square root, let us put the square root now, so that at least the entire square root should be there. That should be there in your mind. So last step we can put, and this is almost the final. Oh, nothing more to simplify, and we will say that this is the final expression, and we can discuss a special case now. Okay, whether to highlight the or whatever it is. I would like to see what will happen when phi is equal to phi prime. So that discussion I want to make. So let us consider a particular important situation. Okay, there is many situation is there where the angles phi and phi prime are equal. Phi and phi prime are equal. What happens when these two are equal? So you can quickly see what will happen. If phi equal to phi prime means what? Phi minus phi prime is 0. So put a 0 there and then write down. See what I am trying to say is phi minus phi prime is 0. If this is 0, cos of 0. Cos of 0 is how much? 1. So the entire expression is 1. So if this entire expression is 1 means now you can add these two. Because this is gone means now you are eligible to add these two. If you add these two, what will happen is this is cos A cos B plus sin A sin B. Therefore that should be a cos of A minus B formula. So that you can now write down, and therefore this equation is going to look somewhat comfortable. So that will be a cos of theta minus theta prime. That's all. So you see that the equation has got simplified considerably, and this is very important because this expression is useful for problems having azimuthal symmetry. So therefore I would like to write down that. So why did we do this is that this expression is useful for problems involving azimuthal symmetry. You know what is azimuthal symmetry, right? The variable phi will disappear. It's already disappeared. That is what it is. Okay, that's all. I think then nothing more is there. I will remove that. So now that the expression is written for d square, I always want to emphasize that there is a square root. Okay, your mind should register that there is a square root running there. So that is why you should remember that d means distance. So in which case the square root has to come. So I would therefore want to write down explicitly that d is the distance, not the d square. So if that is the case, then we can now write down that d is nothing but modulus of r minus r prime. In which case we would like to know how the 1 divided by r minus r prime will look like. because this is what we wanted, right? Because for electric potential. Now let us write down that this is 1 divided by of the entire square root there. So simply copy that entire expression. So our conclusion is that in the case of the spherical polar coordinate system, 1 divided by r minus r prime is going to look like this. So this is first step, or this is how we progress towards understanding the appearance of the 1 divided by r minus r prime. In Cartesian, things are quite simple, so you don't want to do all this work. But because this is spherical polar, no, you have to be more careful, because variables are r theta phi, and therefore the appearance of the equation would be slightly lengthy. Okay, it's not complicated, but it looks as if little lengthy. But what I'm trying to say, I don't want to copy this. You say that the same equation is useful for the azimuthal symmetry problem. So the same thing what I've written, you copy it here. That is what I mean to say. Okay, this is the next part. This is the next part. Let me therefore write down. So this completes the first part. Did you understand what is first part and what is second part? In the beginning, I told you that we are going to have two questions. The first question is what is the distance between the 2 points, and the second question is what is the angle between the two vectors. So now first question is we have addressed the first question. We will now move on to the second question, which means that we are going to ask the question what is the angle between the two vectors. So let me therefore go to the next. I'll move to another place in the screen and then show that particular question, because diagram is same, right? Question is only coming here. So here I have written whatever I have explained already. Explanation is over. Formula I have written down for your convenience. So there is a r vector, there is a r prime vector. It is in such a way that these two numbers are not same. R is not equal to r prime means the 2 points need not stay on the surface of the sphere. Theta is not equal to theta prime means the 2 points will not be on the vertical plane. If phi is not equal to phi prime means the 2 points may not be in the same horizontal plane. That is the meaning. That means this is the most general situation where one point and another point will be somewhere in the sphere, in the spherical polar system. That's the meaning. There are some special cases are there if they are equal. Okay, I'll show you what is that speciality, but this is the most general situation where equality is not there. Arbitrarily you close your eye and put two places and then ask the question what is the angle between them. Okay, these things, what is the vertical plane, what is horizontal plane, I will explain. So that is I will explain and then I will come back, and let me therefore show the original diagram, the first diagram that I started with. So the question is that here this is the place. I have put a gamma here, right? So we are asking the question that if this is an angle gamma, if you are going to identify that particular angle as gamma, can you find what is gamma? That is the question. So what is there in your hand, you should know. What is there in your hand is you have the values for r theta phi, you have the values for r prime theta prime phi prime. You have 6 numbers with you. Using these 6 numbers, can you find the angle gamma? Because angle gamma is not measured. I don't have the number. So only from these 6 numbers, is it possible to find the gamma value? That is a question. And we are going to address, we are going to answer how this is possible to calculate. So let me therefore move to the question. And as I already told you, let us, okay, that we will represent the angle by gamma. Let me therefore, I would like to explain some special cases of the vertical plane and horizontal plane. Okay. After that only let me come back here, because first you have to understand the two special cases. One is vertical plane case and horizontal plane case. Then you can understand what do you mean by not in the vertical plane, not in the horizontal plane, etc. So that point will be clear if I make that additional explanation. Okay, so let me therefore move down and then I will show you what is meant by a vertical plane first of all. Okay. Okay, so this particular diagram you see, I think this is corresponding to horizontal. Can you see the horizontal circle, right? So the angle corresponding to the horizontal circle, horizontal plane is known as the azimuthal angle. So now this diagram will clearly tell you what is equal and what is not equal. You see, what you have to see first of all is there are 2 points are there. This yellow color point and that another point. This is another point. and if you draw the line from the origin to that particular point, then that is called vector. So that vector is the r vector here, and this vector is r prime vector. And now the question is, what is the angle between the two vector, you are asking, right? Now this is the simplest thing where you don't have to do any calculation and directly tell the answer. So these are the two vectors, and the two vectors are lying in the same plane. Are you able to visualize? So for that reason only I am showing this diagram. This diagram will clearly help you to visualize that the two vectors, namely r vector and r prime vector, they lie on the same plane. In which plane it is lying means horizontal plane, because this is x, and if you draw this line, that will be a y axis. Then z axis is this. So it is in the xy plane. So xy plane is the horizontal plane, and which is, you can always see here, some kind of violet color shading is there here. So clearly you are able to visualize the horizontal plane, and both of them lie in the same plane. If it is lying in the same plane, then what is the angle between the two vector means the angle to be measured in the horizontal circle is phi, and therefore the angle should be phi minus phi prime, because this is phi. What is phi prime? Phi prime means from the x-axis you have to measure that. Okay, so from the x-axis always you have to start from x-axis. From the x-axis you count the angle until you reach that vector. If you reach that vector, then that angle is phi prime. So phi minus phi prime should be the difference. Okay, let positive negative, don't worry, that is the angle between the two. That's all about it. So in this particular case, there is no further calculation. Trivially you can tell, quickly you can tell what is the angle between the situation. And therefore here you see, for this particular situation, what I am going to call this as case 1. What is the story is that in most general situation, r need not be equal to r prime. That means the 2 points that I am showing here need not be on the surface of the sphere. One of them can be inside also. See, if you reduce the arrow length, if you reduce the length of the arrow, that means the point will be here. Even then phi minus phi prime is valid, right? Even then it is valid. So the point need not lie on the surface of the sphere. It can also go outside. You elongate the arrow, and then you elongate the arrow up to this. Even then phi minus phi prime is valid, right? Therefore r is not equal to r prime is always acceptable, no problem. This method will work. And then phi is not equal to phi prime, that is clearly visible. Okay, phi is not equal to phi prime, then only you can have two vector. If phi is equal to phi prime means the second vector will be lying on top of the first vector. Therefore phi has to be not equal to phi prime. These two things are clear. Can you tell anything about theta? That is the point. There is a theta here, right? R theta phi, r prime, theta prime, phi prime. Can you tell anything about the theta? So I have already written that they are equal. So you have to tell how thetas are equal. This is the place where you have to think how it is equal, or what should be its value. Whatever be the value, it should be equal. Now in this diagram, whatever I have drawn the diagram, this is the z-axis. And how do you measure the theta angle? Theta angle has to be measured from the z-axis only. Therefore from the z-axis you keep measuring what is the angle from here to here. Like this you have to measure. So if you measure this, then there will be some value. That value is theta prime. Similarly, from the same z-axis you again measure the angle up to this for this particular arrow. So that will be theta. So you got a numerical value for the theta prime. That means from the z-axis like this you measure, and from the z-axis like this you measure. So these two angles will be equal. You must be in a position to see that they are equal, and in this case I have plotted for 90 degree, and therefore at least 90 degree should be visible to you between the, because one is the vertical axis and this is a horizontal plane. So automatically 90 degree is there. So I am going to this diagram will clearly tell you that theta must be equal to theta prime in such situations, and this particular special figure corresponds to 90 degree. So when this kind of special situations happen, what happens is you don't have to struggle and then find out what is the angle between them. Angle between them can be directly written down as phi minus phi prime. But if this kind of special situation, like some kind of special cases are not there, then only trouble comes. Then only you have to do some work. That is what I am trying to explain. Okay, so our conclusion, what did you understand from here is that the given vectors r and r prime, the given vector r and r prime, they lie in the xy plane, namely horizontal plane. That is x vector, I mean this r vector, this r prime vector, both of them lie on the horizontal plane. If it lies on the horizontal plane, then no need of doing any work. Trivially, you can subtract the two angles and say the answer. This is the first case. There is a second case is there where once again the story is very simple. You don't have to do any work. Directly you can tell the answer. So that is the second case. Let me therefore go down and then show what will happen if you are going to measure in the vertical circle. So I just want to go, but before, okay, here. So since I explained that no need of doing any calculation, that the gamma value is directly visible to you. So there is no more calculation. Okay. So let us go to the another case. Case 2. Case 2 will be the one corresponding to the polar angle. So instead of the horizontal circle, now what happens is that you take the vertical plane. So you can see that the vertical plane that it is there is, it's a plane, right? It's a plane and it is in the vertical plane, not in the horizontal. So it is corresponding to the z and then the x. So that kind of vertical plane. And as usual, all other things, there are two vectors are there and all other things are there. And the question is, what is the angle between the two? Now the angle between the two can be quickly written down that it is theta minus theta prime without doing any calculation. And you should know what is the general situation. As usual, r need not be equal to r prime. So one vector can be smaller, one vector can be bigger. You can always draw a big vector like this, even then this is valid. The only important thing is which angles are equal. You have to see the horizontal plane angle will be equal, because if you are going to draw the x-axis, so that is the x-axis that you are going to draw, and then measure their projections. Phi angle measurement is not easy. You have to first project it to the horizontal plane, then only you can take. So when you take that, for this particular any vector that you do in this particular scenario, the phi angle will be the same, which means that the number on the horizontal plane is not going to affect anything, and only the vertical thing will affect. That means only this particular point will be keep on moving. You can move this, and then correspondingly this particular vector also will come, new vector like this will come. Whatever be the case, only theta will vary, phi will not vary. Phi will not vary. Okay, whatever number is there, that will be same for both the vector r and r prime. And therefore what happens is, because one of the angles is equal, then our job is there is nothing to worry about the new calculation. You directly write down theta minus theta prime is the angle between them, and this angle between them is what we are calling as gamma. That's what let me say, that gamma is given by simply theta minus theta prime. So our calculation becomes very simple only in these kinds of special cases. Only two cases. If these two cases are not there, okay, if these two cases are not there, then we have to perform the calculation. That is what is this, that is what I have written here. So if these two cases are not there, means none of them are equal. This is also not equal, that is also not equal, this is also not equal. Now this is the situation where we say that what is that we are writing is that it is not in the vertical plane, not in the horizontal plane. So I would like to highlight that. Of course, the solution method is simple, but first you should understand what is the problem. Statement of the problem should be clear. No? That's why. Okay, the solution is simple. A dot B product rule is AB cos theta. That's all. That's what I am trying to say. And if you know this idea, then we will be able to get the angle between the two vectors. Okay, let us now write down. But this kind of equation is quite simple in Cartesian. Since we are dealing with the polar, spherical polar, you have to convert it into spherical polar. That's what we will do it now. But anyway, two vectors will lie in a plane, right? That is the first point that is that you should know. Question is only in which plane. That's what I was explaining, not till now. Horizontal plane or vertical plane or some other plane. So three options are there. Horizontal plane is one option, vertical plane is second option, some other plane is third option. Depending on that only you have to do the calculation. Okay, two options are clear. Third option means not in the vertical plane, not in the horizontal plane. So therefore, we have to perform some calculation only if it is in the third option. That means other plane, some other plane. Okay. Okay, so you now understand when some calculation is involved and when the calculations are quite simple and trivial. So that much is clear, and therefore let us now start doing the calculation. So how to proceed is that it is very clear. I already told you the hint. The hint is this: the information about the angle. Where is the information about the angle? Is the information about the angle is somehow contained, or we say that yeah, it's available, or we can say it is available inside the quantity, or we say contained in the quantity of the dot product. So which quantity? A dot b. A dot b means what? A dot b means r dot r prime, isn't it? A dot b is two vectors. So here two vectors are r and r prime. So if you somehow know how to take the dot product, then our job is over. So therefore, let us see how to evaluate the r dot r prime, and which can be written as r times er cap. Then you have an r prime times er prime cap. So this is clear, right? This is a vector, but this r is a scalar. So take the magnitude here and then write the unit vector corresponding to that. So similarly, this is the this r prime is the magnitude of the r prime vector. Then what is the direction in which it is showing? That is the corresponding unit vector. So therefore, if you write like this, essentially we are now dealing with the unit vectors in the spherical polar coordinate system. But but you should know one thing. Unit vectors, dealing unit vectors in polar coordinate system is always a little difficult. They are not constant. Why it is difficult means unit vectors in the polar coordinate systems are not constant vectors, whereas unit vectors in the Cartesian coordinate system are constant vectors. So dealing with constant is easy, dealing with variable is difficult. And therefore, dealing with these variable unit vectors are somewhat difficult. And therefore, okay, and because of this reason, we will convert this particular unit vector to the Cartesian. So I have explained why we have to convert to Cartesian, okay? Because unit vectors in the polar coordinate systems are not constants. They are variable. And therefore, let me therefore write down like this. How do you convert it? So the question is clear. How to convert? So anyway, in our discussion, the radius doesn't affect. So therefore, nothing wrong in fixing r equal to 1. And therefore, what happens is we are essentially talking about the dot product of the two unit vectors. And you apply the a dot b formula. A dot b equal to modulus of a, then modulus of b, then you have something like cos theta. So that is what it is. So in our case, we are going to use the symbol gamma. So it is same a dot b formula. So now what do you want? So what do you want means you need to convert this dot product into the Cartesian system. Then we will be knowing whether any simplification can be done. But only thing is that the conversion is it's a matrix conversion. I mean, you need to know the matrix, otherwise you can't do. So if you are not comfortable with this matrix, you have to refer to my lecture under the title of spherical polar coordinate system. There I have given the corresponding matrix, how to convert the unit vectors. So right now I will assume that you know this, and then I will write down the corresponding connection. Connection means what is the relation between the unit vector in the spherical and the unit vector in the Cartesian. So that connection only I am writing, and the connection is given by this kind of a matrix. Quite simple matrix, by the way. Sin theta cos phi, then you have a sin theta sin phi, and then the last term is cos theta. And similarly you have to write down the second row, which is nothing but cos theta cos phi. So after this, this is okay. Let me write down, and then the last one I will write down later. Cos theta sin phi, and then you get a minus sin phi, and finally you have minus sin phi, then you have cos phi, and then you have a 0. Okay, so this is the transformation matrix multiplied by the Cartesian unit vectors. So Cartesian unit vectors are ax, ay, az. Okay, so you'll be getting three relations, right? This is actually a 3 by 3 matrix, means 3 relations are there, but we don't want 3, isn't it? We want only for the AR. See here you have to see this is AR dot AR only we want. We are interested in only AR, but this matrix gives you relation for AR, A theta, A phi. All the expressions you can get it from this matrix. But we don't want so many things. We want only for AR. That means, how do you get AR? AR equal to this row into this column. If you multiply that, no, this row and this column, if you multiply, then you get AR. So that means this term into AX plus this term into AY plus cos theta into AZ, that much is equal to AR. And similarly, if you want to do, you can do for A theta, but anyway, we are not interested. Therefore, let us not do any simplification for A theta and A phi. So we don't want. So I want to put a into mark for these two things. And we are interested in taking only the AR part. Okay. So that's what I'm trying to do. So probably I'll write down that. So I'll put a tick mark there, and then the other two things we don't want. So we don't want A theta, we don't want A phi. Okay. So let us therefore simplify the expression for the AR unit vector. So AR unit vector equal to, simply write down that. That's all. That is easy. So sin theta cos phi. Then you have AX unit vector cap. That is first term, plus then that is the second term. Then you have the last term. Okay, that's all. Okay, we don't want A theta A phi, and that's it, over. So similarly, you can write it for the primed version, AR prime. Prime means what? Everywhere you put prime. Okay, equation is same. All variables you put a prime, that's all, including unit vector. AX also you have to put AX prime, because that is a unit vector corresponding to that vector. So now we are ready. We have, but there is no space now. The board is full. So let me go somewhere else where you have an empty place. Then we will continue. Okay. So now that you have you have AR also. You have AR dot. I mean AR prime also. So once you have the two vectors now, taking dot product is quite simple. So let us take the dot product between the two vectors AR cap and AR prime. And only thing is that you should have it in your note, so that again copy that. Only thing is, when you are taking dot product, now put a dot. So this is dot, the second part. So component wise, dot product, x component, that is the first part over. Then plus ay component, again you multiply. So these are the y component. So ay, then put a dot product, then the second term. So this is also over. Then you have the last term where you have only a cos theta az. Then you put a dot, then primed version, and that's all. So dot product is fairly simple. There's nothing to do. And now comes the point. So you see here, AX, there is AX cap. This is unit vector. So unit vector is there, dot is there, another unit vector is there. So unit vector dot unit vector. And remember, this is Cartesian. That is why I told Cartesian. In the case of the spherical polar coordinate system, unit vector dot unit vector is not one. So this is where the trouble comes. I already told you. This is already there. This is unit vector dot unit vector. We can't write one. Okay, that is the reason why we converted. The Cartesian system, what is the advantage is, unit vector dot unit vector will be always one in the same direction, whether it is x or whether it is x prime. Similarly, if you are going to take ax dot ay, this kind of a dot, it is always 0. But in this particular case, what happens is, because both of them are pointing in two different directions, their dot product will not be 1 always. Because these two things are pointing in two different directions. That is what I told variable. Here it is not the story. In which direction ax will point? You know which direction it will point. It is along the x-axis. In which direction this will point? I mean, this will also point in the x-axis. Then what is that prime means? Prime means another vector. Another vector is okay. Okay, you have two vectors, but unit vector will not change. Unit vector will be pointing in the same x-axis here. But here, that's what here it is. Story is different. You don't have a fixed r-axis. R-axis. How many r-axis is there in a sphere? Infinitely many r-axis are there. So unit vector is not a single unit vector. Infinitely many unit vectors are there along the radial direction. Which means what? What I mean to say is, you can draw infinitely many radius to a sphere. How many radius can you draw in a sphere? I will draw a sphere, and if I ask you to draw a radius, How many radius you can draw? You can draw infinitely many radius. Each radius has its own unit vector. Come to the Cartesian. Okay, draw x-axis and draw unit vector means only one option for you. You can't draw three x-axis. Okay, therefore this is constant. Dealing with the Cartesian coordinate is easy. Dealing with polar is not that simple. And that is the purpose, or that is the reason why we are converting into the Cartesian system and now doing the simplification. Now the simplification is very easy because ax dot this ax prime is 1. So these two things are 1 and therefore dot product disappears. The remaining things are scalar quantities. Now vector quantity has disappeared. Okay, so let us simplify therefore. That's all. That is the first term. Then you have a plus. You have a sin theta prime. Then you have a sin phi prime. Over last term is easy, cos theta prime. And that's all. Again, you can take a little amount of information common. I will take sin theta prime common, and what is left out can be written as cos of a minus b formula. And I want to emphasize that for to avoid confusion, additional bracket, and that cannot be simplified. You write down that. So as you can see, the purpose of the additional bracket that I am going to put here is to avoid a possible confusion that you try to merge the sin theta prime, cos theta prime, and it looks as if it is cos of a minus b formula. Okay, so that kind of you may write down as cos of theta minus theta prime, okay, by mistake. So to avoid the possible mistake, we are putting some additional brackets here, and our job is over. We have simplified, but only thing is that, okay, this is your cos gamma. Of course, you must know how it is cos gamma. This is a product a dot b. What is a dot b? A dot b is equal to modulus of first vector, modulus of second vector, then angle between the two vector. And because this is a unit vector, because these two are unit vector, modulus is 1. Therefore, 1 into 1 into angle between them is gamma. Therefore, 1 into 1 into cos gamma. That is what I am writing. And therefore, this quantity is now simplified. Now you can delete this particular point and keep this, because we are now interested in gamma. Therefore, now what is the answer? Gamma should be equal to cos inverse of this entire expression. So that is the answer. So let me therefore highlight that this is our expression that we are interested in. So cos inverse of the entire expression, I will not write down, but the entire thing you copy, and that's it. And that is the gamma. So now you know how to evaluate the gamma in the general situation where the vectors don't lie in the vertical plane, don't lie in the horizontal plane. Okay, so keep this relation. And now the interesting point comes. Once you have this equation, you must be in a position to recognize, did you see this equation anytime elsewhere? Did you see this equation anytime elsewhere? You have to tell yes, because just some, I don't know, some 20 minutes back we have seen the same expression. I think it is here. Are you able to recognize that this is there? You must be now in a position to recognize that the expression that I am going to highlight here is the same expression, identically same expression that you got it now. And therefore, now you understand that the entire expression inside the bracket is nothing but cos gamma. Isn't it? So this is what is the cos gamma according to our current calculation. And therefore what happens is, instead of writing the big expression like that, you can now write cos gamma. So let us therefore rewrite. I would like to rewrite that here. So therefore we can write down that the inverse of the distance, no, d inverse. So d inverse is equal to 1 over this, which is equal to, you put the 1 divided by square root, and then you write r square plus r prime square minus 2r into cos gamma. So now the big expression has become cos gamma. So the advantage is that this equation looks much elegant and simple when compared to the previous big expression. But however, remember, it did not become simple, but gamma expression is big, no? That is there anyway. So gamma is given by equation B. So that will not disappear anyway. But now if you write in this particular style, the equation looks very elegant. So you can see the equation looks very elegant, So this is the most general situation where things don't appear in the horizontal plane, vertical plane. But this is a special situation where the vectors lie in the where the vectors lie in the vertical plane. That means plane containing z axis. So in that case, the equation is anyway simple. But in this case, the equation is a little bit lengthy, but however, the cos gamma term contains that lengthy expression. That should be there. That's why I have written here, where gamma is given by equation b. That lengthy expression is there anyway. That will not disappear. But we can now write down in this particular style so that this looks very similar to this, and therefore it is easy to remember. And this is very important. The entire expression that you have written is for the inverse of the distance. So 1 divided by this particular r. So our conclusion is therefore that somehow we are able to obtain the expression for the 1 divided by r minus r prime. But however, we have made some good amount of progress actually in understanding how the 1 divided by r minus r prime is going to look like. So what can be done further, or how to understand in what way associated Legendre polynomial is entering into picture. So that discussion we will see in the next class.